first thing for drawing and interpreting graphs is the intercepts, where it crosses the horizontal axis and the vertical axis. Usually have an important move when we are interpreting graphs. So the horizontal intercept, if it's an x-axis, that's the x-intercept. So take a look at the word, how it's spelled, intercept. Not intersect with a C. So it's not two lines that are intersecting, it's the intercept. And that's where it crosses the horizontal axis. Okay, the vertical intercept is where it crosses the vertical axis. Makes sense. So they, in an application, they are key points. So if we take a look here at the first one, the graph shows the fuel consumption of a scooter with a full tank of gas. Okay, so the volume there, and this is the distance the scooter travels. So write the coordinates of the points where the graph intersects the axis. Okay, so that's with a C because it intersects another line, but it's actually called an x-intercept, and explain what these points represent. So the vertical intercept just a sec here. What is going on? So that's 0, 8. Horizontal intercept is 200. Zero. So the vertical means the initial volume is 8 liters. Here the length of the distance traveled to use up the entire tank of the gas is 200 kilometers. So it takes 200 kilometers to use all the fuel in the tank. It does matter the order here. It has to be 0, 8 because the horizontal value of that point is 0 and the vertical value is 8. 8, 0 would be a point over, well, it wouldn't be on the graph, right? 8 here doesn't have a point of 0. So the first value is your horizontal or your independent value. Because that's the coordinates of this point, 0, 8. Okay, the horizontal value goes first. 200 is the horizontal value. The vertical value is 0. So 200 goes first and then 0. So this you want to look, are they joined up with a continuous line? Yes, they are. So it's not skipping from each distance. So it's going to be, I'll use set builder for this. And so look at the variable. We need to use D for distance. So all the values of D, where D is between 0 and 200. So that's what we've been doing the last couple of days. Question? You can use the format that we used yesterday. I'm just using set builder today for this one. I'll use interval in the next one. But yeah, you can use either. You just can't mix and match. So within the question, use the same notation. So range here, that's going to be capital V for volume. And the smallest is 0, the biggest is 8. Capital R is fine. Yes. Okay. So next one, different graph to interpret. This says, this graph shows the depth of water in a bathtub as a function of time. So what does each segment of the graph represent? Compare your description with a person next to you or near you. Are both your stories the same? Should they be the same? Okay, so they should be pretty similar. So from O to A, I'll get you started, or I'll write it down. You can help me. So from O to A, remember, what is this vertical? It's the depth of water. So at time 0, take a look. Is there any water in the tank at time 0? No, because its coordinates are 0, 0. So no water in the tank. As time goes on, the depth is increasing. So is the tap turned on? Yes, the water's going in the tank. Okay? It's turned on the same amount. I'm not switching it. You know how sometimes you turn on the tap and you turn it on a little bit and then you turn it on more? So that would not be a straight line when we graphed it. This would be turning it on and leaving it like that, so it fills up at a constant rate. So it's a line as opposed to a curve. So this, from O to A, you're filling up the bathtub, the tub, at a constant rate. Okay, so I'm going to pause here. You're going to fill in what you think happens from A to B, then from B to C. And so, okay, so from A to B, the water level is not changing. So likely the tap is turned off. You keep the tap on, the water level is going to change. Okay, now from B to C, maybe you turn it on again, or what else? If you're going to go have a bath, what do you think's happening, Avery? Yeah, someone gets in the bath. Okay, in this case, it doesn't say who it is, so someone gets in the bath, so the water level increases, right? In a pretty fast amount of time. Notice how that's steeper than the first line segment. Because when you go in, you're getting in the bathtub pretty quickly and sitting down in it. So here I go, person gets into the tub. Go. Okay, then C to D, they're obviously having their bath. They're sitting in the tub. Yep, then D to E, they get out of the tub. So the person gets out of the tub, then waits for a couple of, how long is this? Probably that's like a minute. And then what do? They wait a minute and they pull the plug in the tub. So E to F, they're probably, yep, drying off. So waiting a minute, toweling off, and then pulling the plug. For the water to drain. Well, that's just what this person decided, okay? Doesn't mean that you have to do that when you have a bath. You can pull the plug earlier. You can get in while it's still running, but this person did it in steps. If you had done it a different way, the graph would have looked different, right? So if you had got into the bath while the water was still going, then it would have had from this line here, it would have gone that steep line, even steeper right from there, no horizontal. So it would have been a different graph. Okay, so state the intercepts here. So 0, 0. So that means no water in the tub to start. And then basically the whole process of taking the bath would be 24 minutes, right? From start to finish. So then the other intercept is 24, 0. So it takes 24 minutes to run the tub, have a bath, and drain the tub. So I'll maybe say for the whole bath process. That saves a bit of space. Okay. You write the domain and range. So let's say I did my last one in Set Builder. Why don't you do the domain and range in interval? Or if you did the first one in interval, do this one in Set Builder. Okay. And then decide if it's a function or not. Okay, these are all types of questions that you will see on your test.
How do you write
I've already said twice when the test is. Look on your timeline. I've already said it twice today. I think I've already said that twice today. Yes. Okay, so domain. So the whole bath process takes 24 minutes. So you're going from 0 to 24 inclusive. So that would be 0 to 24. Avery. The order of the entries within it, yeah, so you can't put 0, 24 there. The independent variable goes first. The first value, the horizontal value, the x value always goes first.
So does that mean the range goes from like 0 to
the height of the tub?
30 or something?
Yeah, so you want to look at the scale here. And if you look at the graph and do a quick vertical line test, right? You put your vertical line, there's nowhere where it's vertical. So it just touches once, which means it is a function. Okay, next one. So folks, I need quiet. So next one, question 3. So this is costs and masses of various bags of popcorn. So notice they're different points. They are not joined up. So it says each point represents a bag of popping corn. So depends what brand it is, what size the bag is, all that kind of stuff. So which bag is the most expensive and how much does it cost? So just looking at the highest cost value. So the highest point is C. So C is the most expensive, and it costs, so if you take a look at the scale, each grid is $1, so it costs $7. Okay, which bag has the least mass? So now you want to look horizontally for the one that has the smallest mass, so that would be B. What is that mass? Now again, you're going to have to estimate. Looks like each grid is 200. So halfway in between would be 100. So I'd say that's about 500 grams. Okay, you look for which have the same mass. The ones that have the same mass are on the vertical line there, D and E. What is it? Again, halfway between 1600 and 2000 is 1800 grams. Which bags cost the same? Horizontal line, that would be A and E. What is that cost? That's $4. Okay, and then which of bags C or D, so we're just comparing these two, has the better value for money? So this is what we call unit cost sometimes. So we take the cost, so C is $7 for 1600 grams. D is, what does that look like? 550 for 1800 grams. Okay, so take out your calculator. Now it'll be very small decimals because you're dividing by large numbers. I'll do it on here. So you can go, what you can do, I just did this in my, did this morning with 10-3. So we're dividing by 1600, okay? That's not even a cent per gram. So why don't you multiply by 100 to get the price for 100 grams, okay? Keep it in your calculator. Then do D, 550 divided by 1800 grams times by 100. So we're getting the price for the same weight. And so which is the better one? Is the bigger number the better or the smaller? Smaller, right? You want the cheapest price. So D is the better deal. Okay, and often that's the case. The bigger the package of an item, the cheaper it is. But sometimes that depends on if you're comparing different brands. So then write the domain and range of the graph. Okay, notice how they are not connected. So domain here, we do our squiggly brackets. So we can only do the squiggly bracket set builder method. We cannot use interval notation.
Why not?
Because it's not continuous, and that's in your notes. Question? Well, in this case, no, it wouldn't take, but if I said determine, then you would have to show work. So in this case, no. Okay, so here you take a look at each of the values. So that was 500, and then 900, and then 1600, and then 1800. And then the range would be 2, 4, what's that, 5.5 or 550, and 7. Is this a function?
Yes.
No.
No.
Vertical line, there's 2 different values for a bag that is 1,800 grams. So no, it is not a function. Okay, so those are discrete values. Remember, discrete are not joined up. You have to know that word. Continuous, they're joined with a line. So your pencil, when you graph a continuous relation, it doesn't lift off the paper. That's a kind of a trick to remembering it. Oops. Okay. So these 2 questions are like the ones that we gave you yesterday, that extra sheet after your matching game. It says, given the following descriptions of domain and range, and if the relation is a function, sketch a possible graph. So here, x has to be less than 5. So I'm going to just kind of do like a dotted line with a pencil. I know I can't have any points above there. And then y has to be, oh, sorry, that's x. Got to mix back up here. X has to be less than or equal to 5. So vertically here, that line. So my x values have to be to the left of that vertical line I just drew. And y has to be between -2 and 5. So I could have kept that. Okay, so I'm just kind of mapping it out for myself. Okay, so what could we do? We could do a curve, we could do some lines. What we have to be careful of is what's included. So this one has an equal to, so I can have a line here, right? So I could have part of it like that, just a horizontal line. Okay, and that's good. That part will take care of going to negative infinity and not going higher than 5. But then remember, x has to be less than 5 and y has to be greater than -2. So what I might want to do is put an open circle here and just join that up. Okay, and then check it. Maybe you have to do a couple of drawings before you get it right. So now if you look at that, check what my domain is. My domain, it's an open circle at x is 5, so x has to be less than 5 because the arrow is going to the left. So I've got that part right. Then y has to be greater than -2 but not included, so that's good. And it's continuous up to 5 and it has to include it. So that's a good graph. That works. Could have different ones. So that says it's a function, okay, and it works. I've got a function there. But the next one says I want to do something that's not a function. So that means I have to have, in some vertical line somewhere, I have to have 2 points or more than 2 points, right? So this says x can be anything. So I'm just kind of going to remind myself that it's going to go both directions. And then y is greater than or equal to -6. So again, I'm going to just help myself out here with a dotted line. Okay. And it is not a function. Okay. So there's an infinite number that we could do. We can include this, right? Because it's got an equal sign, and it has to go all the way upwards too, right? Because it's y greater than or equal to -6. So you might want to, like just thinking about it right now, I could go start with something like this. I'll just erase this part. And don't copy me yet. So if I did that with my domain and range be correct? So don't copy what I have there. Just tell me, would my domain and range be correct? Yes. Is that a function? Yes. And so that says I don't want it to be a function. So, I don't know, maybe I could go do a zigzag kind of thing. So I could go back and forth like that. Okay. Now, is that a function?
No.
No. Yes. Correct. What kind of straight line? Vertical? Well, you could do a straight line, but it has to stop at -6. So I could do this one. Oh, no, I couldn't do that because it's x element of the set of reals, right? So I need to get all the x values too. That would only be one x value. So there's different ones, but that one would work. Hardest part is getting the domain and range. And then once you do that, think about, okay, if it's supposed to be a function, make sure it only crosses once. If it's not supposed to be a function, do a little zigzag or something. Probably, I think I printed out the they have something that looks different, has a different zigzag. They have a vertical part to it. The other one looks actually the same as mine too, but there's more than one possible choice. Okay. Oh, sorry, I got to go back, right? There's one more on that page. Okay, this is one where you have to draw a graph. Okay, folks, listening? Okay, another bathtub question. It's popular. So sketch a graph to represent the situation. You put the plug in the bath and turn on the taps. So first of all, this is where I said it's handy to have a ruler. So do a horizontal axis and a vertical axis. Okay, so you put the plug in the bath and turn on the taps. You leave the bathroom and return to discover that the bathtub has overflowed. So what happens? Have you ever overflowed? Hopefully not the bathtub, but maybe a sink or even a jug of water. Does the height of the water in the bathtub change? It overflow? No, it stays, and all the water goes on the floor, right, and the tile or whatever, and floods your bathroom. So this is going to increase with a straight line and then be horizontal. All the other water is going outside of the bathtub and flooding the bathroom. Okay, so you come back, you realize that it's overflowed, you turn off the taps and pull out the plug to let out some water. Then you put the plug back in. So think about what happens. So you come in here and you realize, so you put the plug in. So it's going to stop, right? It's still full. You put the plug in, it's still going to be full because all the water is going somewhere else. Okay. Oh, sorry. You put the plug's in, you put in the water, it overflows. You come in, you find it, and then you pull out the plug, so it's going to start draining. Okay. And then you put the plug back in. So you're not going to let it drain all the way. So then you put the plug back in, and then it levels out again. Okay. So something like that. This would be time. And this is height of water. Okay. So that's the last one. The rest is practice.
No, is it? still one more page and it's just practice.
Oh, yeah, sorry. Okay, turn over to the next. Okay, so another one where we have to interpret the graph. This says a student's energy level is related to the time of day. Describe these changes in energy level shown in the given graph and come up with an explanation of the changes. So this initial point here, that's at the beginning of the day. So that's when you wake up in the morning. Okay, typically you should have, so point A, we'll call it A, is when a student wakes up. Notice how it rises a little bit. For most students, what's that rise in energy because of? Eating breakfast. Okay, and then what's happening during C? You're going to school, right? So you're using energy up at school in the morning. Well, the food gives you energy. Well, this is typically what it should be, but it depends what you eat and if you eat and all that kind of stuff. So some people skip breakfast, but they don't get the energy, right? So some people have it anyway. So school in the morning, okay? So it dips kind of low here. What do you think is happening in D? Lunch, eating lunch and resting, right? So D, lunchtime. So food and a break. Up to here. And then E would be afternoon classes, right? Okay, and then what would be F? Sorry, you have to wait for F to show up. Dinner, right? Okay, then F is dinner and break from schoolwork, probably. Okay, or break from sports or activities. And then G would be, so homework, practice for sports, yeah, so basically by the end of the day, just the general wear and tear of the day, you are tired by the end, right? And then you go to sleep, and sleep restores you. Okay, next one, we're going to draw some more graphs. Do you think, yeah, exactly. So do you think the height age graph should be a straight line going up like this?
No, it shouldn't.
Anyone have little brothers and sisters?
Yes.
Yeah. Did they grow a lot in the first few years?
No. They're pretty short.
Well, in general, so you guys now, you might still be growing taller, but at a much smaller rate. A baby is like this, and then by the time they're 2 years old, they're like this tall, right? And then 4 years old, they're this tall. They're growing quickly. If you grew that much now in 2 years, from what the height you are at now, you would be a giant, okay? So you grow a lot when you're little. Then you level off. So you guys probably haven't leveled off yet, okay? I've leveled off. And at some time, because I'm getting old, at some point, old people get shorter. And my mom is a prime example. She's actually, it's scary how much she lost about 6 inches in a year. So she's in a lot of pain in her back because her spine has become curved, right? And it's shrunk. So basically, in general, you're growing really fast at the beginning. Then you start to level off here, and then you actually start to go down a bit. Okay, so something like that. Okay, anyone been on a Ferris wheel before? Few of you? Okay, so it's a circular wheel. Yeah, so it's when you measure the height. Okay, listening please. You're going to actually spend a lot of time in grade 12 math on Ferris wheel questions. So when you're talking about the height above ground, when you first are on the wheel here, if this is a Ferris wheel, your first part of your rotation, you're not increasing in height very much. But then as you get to this point, you're increasing in height quite quickly. Then you slow down, and at this point, you're at your maximum height. You're never going to go higher than the Ferris wheel. And then you're going to come back down again. So if you get on the Ferris wheel at the bottom, I'm not going to put it right at 0, 0. Why do you think I'm not going to put my height right at 0, 0 for the Ferris wheel? That's right. Otherwise, you're going to scrape the bottom of the ground and scrape the ground with your carriage that you're sitting in, right? And then you'll hurt yourself. So here it's going to go up and then down and then up and then down and then up, etc. Okay? It's actually called a sinusoidal function. So, as I said, Math 30, -1 or -2, you'll be doing that. Okay, so time it takes you to walk to school is related to how fast you walk. So if you walk really fast, do you get to school faster? Yeah. If you walk slow, it takes a long time, right? So this was a graph that we had actually in an earlier lesson. So as the speed increases, our time to get to school gets closer to 0. Oops, let me do this again. Okay, so I'm just going to show that part of it. And then as the speed is slower, it's going to take almost infinity to get there. Remember, we had a graph like this, so look back in your notes. It approaches each axis, but doesn't touch it, because there isn't something like instant time, right? In our real life. Okay. And then a matching thing here. So we need to match and say which graph number or graph letter it represents. So there's 6 descriptions and 6 graphs, so probably they all have one. So the temperature of the water in a bathtub is related to the number of minutes that have, guys, stop. Temperature of the water in a bathtub is related to the number of minutes that have passed since you filled the tub. What happens once you fill the tub? Does it get warmer or colder? Colder. Does it ever get colder than your room temperature? No, never. Okay, that's called an exponential function. Again, we're going to talk about that in Math 30 as well, but you'll also talk about it in science. So it's going to approach room temperature. It's going to approach a horizontal line, just like that speed time graph. So all of this one doesn't approach the horizontal axis. This one looks like it's stopping there. Okay. This one is discrete, so that doesn't make sense. This goes back down to 0. That doesn't make sense. but this one does. It's basically, this would be your room temperature here. And so that it starts out warmer and then approaches the room temperature. So that's going to be E. The amount of gasoline remaining in a car's gas tank is related to how long it's been driven at a constant speed. So the more you drive, the more the gas is being used up. Okay, so the gas remaining means that's going to get lower, not higher, right? Because you're using up gas. So we don't want this one because that's going up. We don't want this one because it's changing. It's actually stopped. And it's never going to stop using fuel if you're driving. This one's discrete, so that doesn't make sense. It's got to be this one. Okay, here's the volume in the tank. As you drive at a constant rate, the volume is being used up. Okay, folks, put your phones away. Like, we're almost done. Altitude of an airplane traveling from Calgary to Vancouver is related to the time in the air. Okay, so been on a plane. Some of these aren't like specifically accurate, but think in general. So you take off, you go up in the air, and then, Avery, what were you doing here? Exactly. It levels out, and then it comes back down, so it's D. Now, technically, when you are taking off, you're gradually going up until it's a straight line. So these would actually be a little bit curved here, and obviously when you're landing, you got to come down and then slowly land. Otherwise, you don't want to go like that. Yeah. Okay, phones away again. Cost of parking at the airport is related to the number of hours parked. So you don't have, typically, you don't pay for part hours, right? So you have to pay for full hours. So you want to look here. You might think this one, but then if this is time, that's skipping, saying that if we say park for 1.5 hours, we wouldn't pay anything. So it's got to be this step function here. So this is saying that for the up to the first hour, you pay the same rate. Then for the second hour, you pay the same. And then the third hour, you pay the same. So that would be A. Okay, Ray, put your phone away, please. Cost of a family flying to Vancouver. Okay, can you pay for half of a person? Or half of a flight? No. So it's the price per person. It's discrete. So that would be C. And then the amount of water in a small swimming pool is related to how long it's been running in. That's like the bathtub. That would be F. Okay. And then I think now we're at the practice. Correct? Yep. So you have to check in. It takes about 10 minutes. So you have about 6 to 15. So you have about 9 minutes before the check-in.